All is good.
Excellent. All right. Well, let's get started. We got some people still filing in here, but just wanted to say good morning, everybody. Welcome to the 2021 DSI End User Roundtable. We went on a little hiatus with our webinars for a couple months, but we're coming back with a bang. We had our CDS and NID Roundtable on Tuesday. I wanted to say thank you to Jerry Hunt and Travis Reynolds for organizing and hosting that. Wasn't able to make that. But today we are hosting some of our favorite industry experts in the world of dry sorbent injection. So before we get into introducing our expert panel today, we wanted to give a special shout out to our sponsors, as we don't do these things without their support. So they keep DSUA running, keep it strong. I'm going to be brief with the shout outs to allow more time and engagement with interacting with our panel today. But just a quick recap of our sponsors. Our platinum sponsors are Luas North America, IGS, Gecko Robotics, Redicam, RPM Solutions, National Filter Media, General Electric, Mississippi Lime, and Duramar. Want to say a thank you to those companies for being platinum sponsors of the organization. Our gold sponsors are Reaction Analytics Solutions, Primex, US Lime, and Noltec Systems. Thank you very much for being gold sponsors to you guys as well. And then lastly, Leckler, Atlas Carbon, and Carton Fujikin as our silver sponsors. So we appreciate all the support you give us. So also as a reminder, we always encourage audience participation in these. So we've done this enough. Send your questions to the Zoom Q&A portal. And Jerry and I will help organize and do our best to get you the answers to the questions you want to ask. So let's get started. Without further ado, let's get into introductions. I'm going to give 15 to 30 seconds to each of our panelists to kind of tell us who they are, what they do. Chad, why don't you start? What do you do? Who are you? And what's your primary responsibilities at Duke?
All right. So Chad Donner with Duke Energy. Primary responsibilities are DSI, SME, but get into a lot of flue gas process issues, basically from the boiler all the way to the stack. As far as DSI systems, we've got 6 sites with several DSI units per site, one with an SBS injection system. And we injected several different locations from SCR inlet, SCR outlet, ESP outlet, and various targets for those different locations, as in what their goals are. So
yeah, I appreciate you joining us today, Chad. Chad's obviously a longtime contributor to DSUA. He's got multiple presentations under his belt with us, so thank you for joining us today, man. Don, you're up next.
I'm the environmental manager at Florem USA. We're a porcelain tile manufacturer in Clarksville, Tennessee, and I have a very different approach than these utilities in that on a good day we feed 2 tons of dry sorbent a day, and it's a much more simplistic approach. We're after acid gases after the firing kilns.
Yep. No, and we appreciate you being part of this panel, representing the industrial boilers we call it. So thank you for joining today, Don. Dave, you're up next.
Dave Luchtenberg. I'm with American Electric Power. We have DSI systems for SO2 control and SO3 control. For SO2, our sorbent of choice is sodium bicarbonate. For SO3, we're currently using Trona, but I'm leading a program to convert all those systems to inject hydrated lime. We're sort of unifying on using SCR inlet for our injection location. And, I think I gave a talk on that a few months back. But I'm happy to be here and looking forward to it.
We are too, Dave. Thank you for joining. And last but certainly not least, Haley Turner. I know, just FYI, it wouldn't be 2021 without having some some audio difficulties 10 minutes before the webinar. So Haley's calling in through a phone on my desk, but everything's loud and clear here, right, Haley?
I think so. I can hear you all fine. So just somebody wave if you can't hear me. But I'm Haley Turner. I work for Louisville Gas and Electric, and I'm stationed at the Trimble County facility, but we all work together with 4 other facilities that we have. And I don't just do DSI, anything AQCF from the SCR out is kind of my realm, and CCRs and all that stuff. But I do also do the DSI systems. And we normally feed before the heaters and after the air heaters as secondary, or before the bag houses. So before the air heaters is our primary point of injection, and it's for SO3 control and for air heater focus control.
No, thank you, Haley. And yeah, this panel represents a wide range of expertise and application. So I'm really looking forward to this panel. And this is obviously recorded. So if you get pulled away or aren't able to make it today, you certainly can go back and rewatch and review. That's what the DSUA is for. We're here to document the knowledge we have today. Okay, so I kind of have certain buckets of questions that we're trying to address today. There's a little bit of more general market related, which I think we're all interested in, and then a lot of meat and potatoes related to DSI specific questions, and then kind of wrapping up with more mentorship type of growth type of questions. So we'll start with the market related questions. I believe Matt Wilson at TVA, give big kudos for suggesting a kickoff with this question, because I think it's on a lot of our minds. The 5-letter word, COVID. We're going to start off with that. So specifically, my first question of the day is specifically in a post-COVID economy, we've experienced shortages and logistical challenges. And we are curious how these challenges have affected your companies and what your companies are trying to do to solve them. And I want to start off with Don. Don, would you mind kind of giving us your thoughts on that question?
Our biggest challenges, I think, are not particularly unique in that they've just been raw material delivery, finished goods shipment, the whole logistical end, either end of the process. And our primary tool for handling it as of late has been multiple vendors. We've got a variety of trucking companies on either end. We've got a variety of options to ensure that we can have product in or out. And for example, for our modified hydrate, we just order extra, stay ahead, so that if we miss a truck, we're still good. It's just a matter of planning ahead.
Yep. So more conscious efforts in the planning and risk mitigation side of things. So, and is it working?
So far, we've not been caught too flat-footed. Raw materials are our big challenge. We're down to maybe a 2-day supply in the raw material end, and as quick as we burn through it, that's a challenge. Right.
And Dave, similar story for you. What do you think, Dave?
Yeah, the Toyota just-in-time delivery model, right? So when COVID hit, AEP, we took a step back, and we really sort of dug in and cut back a lot of capital. And at the time, it was the right thing to do. I wish we hadn't have done that, but looking back, I don't know what else we could have done, because there was a lot of uncertainty then. But what that's done to us is, we've restarted a few of those projects. 2 of those are mine. And what that's done to us is that it's made everything a lot more expensive, because things are more expensive and they take longer. So it takes a little more planning to execute a project now than it used to. And the other big thing for us, and I think this is pretty well utility wide in the industry, is that, it's a whole lot harder to get coal now than it used to be, which is, I'm not sure how that happened. I think what's going on is the miners are selling it overseas because they can get a better price. So, power prices are great right now, but half the units don't have enough coal to keep running. So it's a paradigm shift that no one saw coming. We're still trying to figure it out, quite honestly.
Yeah, no, that's a really good point. And actually, I'm always the silver lining guy, and I know that we've been disappointed with how projects are getting more expensive and longer lead times, but I hope once things have to get better, so we're gonna have a rebound of things should be cheaper and come quicker. Like hopefully it'll be offset pretty quick. But and Haley, I know that you and I have talked before. I mean, Dave, you brought up a good point on the coal shortages. That I don't think is a problem that a lot of us saw coming. Haley, I know you and I have talked about that. I believe LG&E is a similar thing. But what do you think about this question on just COVID in general and impacting shortages, logistics, and the like?
Yeah, the coal has been a big deal. We've the fleet because of it. We, are running test services and aren't necessarily the cheapest thing to run to be able to build up inventory to get ready for the winter.
We have our co-owners
are part of PJM, and I know we have to fill out like a weekly survey for them, telling them how much coal we have on site. We have to also, they've added hydrated lime to that, so we have to tell them how many days worth of hydrated lime we have on site, and it's just kind of, I think, for them to feel more comfortable that we're able to deliver that we're supposed to. And one of the things that's affected us, which takes
parts in general have been
so especially with we have to order things ahead of time, and from some suppliers we've gotten that we can't get it there to you in time, and that's been a problem. Also, the cost of things have gone up quite a bit. Trucking has been an issue, whether it's being able to find people to actually drive the trucks or a bunch of them get sick and so are quarantined and ship. So
the big thing we do is we just make sure that we have
options as far as being able to get things from different places, and we have as much inventory on site and utilize that and keep it at the maximum when we can.
No, that's really good. Yeah, I think obviously this problem is not isolated to any one company. So hopefully there's a little bit of relief, and misery loves company, I guess. But Chad, what do you think? How's this impacting Duke?
Yeah, so I would just echo what everybody else has pretty much already said. With coal supplies and things, I've heard that we're digging coal off of our piles that hasn't been seen since the 70s because, it's just, you can't get it and you got to run. So we pretty much diminished our coal supplies pretty bad to the point that now we're, artificially raising costs on units to try and build inventory for the winter. And on top of that, the coal that we're getting we're taking anything we can get. So it's not what we would like to have. We've got higher mercury, we've got higher sulfur, higher chlorine, a lot of things that are outside of our norm. Coal, and then hydrated lime deliveries. We've come close to running out of hydrated lime several times. And, I've got relatively close relationships with all the lime suppliers. I used to be able to reach out and say, hey, we're running pretty short. What's quickest you can get us something? And then, trucking has been an issue. So, trying to keep our inventory levels higher, just so we don't get ourselves into those situations. And then I would say, something I heard on the CDS call earlier this week is, labor and resources for doing projects, outages, all of that has been extremely strained. I think Matt mentioned something about having a warm body isn't necessarily easy to get anymore. And I will second that. It has been a challenge doing projects of any sort, and then not just with contractors, but internal resources to run the work and to kind of address some of the issues that come up. So at Duke, we've been getting more and more involved in day-to-day activities at all of the plants, just because there isn't that level of oversight or the knowledge with turnover and things like that as of late to kind of know what some of those issues are.
Yeah, it was interesting to hear that folks say that outages getting canceled or extending even longer, because I know both what that means to a coal-fired power plant or really anybody, but it's a pretty massive effort, and skipping an outage can obviously lead to some additional challenges down the road. So it's interesting to hear that feedback. And it sounds like it's the same for you folks here too.
Yep, absolutely.
Sorry, my mute button got stuck there. So I just wanted to keep it kind of general to let you guys get more specific on where you guys want to take this with some of the lines of questioning. But in general, in terms of the things you're trying to address from an air pollution control perspective, more importantly around DSI and the pollutants you're trying to capture, what's kind of been the biggest problem today that you guys are, or in the recent past, or even the upcoming future, you guys are trying to address? And what are you guys trying to implement to kind of solve those problems?
I mean, I'll start. Air pollution is really, it's at this point, it's more of an O&M thing, to be honest with you. I mean, other than me switching where we inject and switching our sorbent around, for the most part, for us, it's, maintaining catalyst management program. It's, making sure the grind's good on your scrubber. It's, the mundane things that keep things reliable. But, right now, our biggest challenge from a general pollution control perspective is getting all of our CCR ELG projects executed. Those are pretty big jobs that are coming up. And, we actually just had a recent regulatory ruling that's going to keep one of our plants open that we weren't sure about. So that was a big win for us. So that's a good thing. But, those are big jobs or big transitions. We're getting away from using water for using ponds for bottom ash. And inevitably, air pollution control solutions cause water pollution problems. And, so we're having to retrofit our wastewater treatment plants for selenium control. It's crazy, the things you wouldn't even have thought of 5-10 years ago that now are like a big deal.
So it seems like, Dave, what drives a lot, even some of the decision-making process, I think with specific to what makes kind of DSI unique and interesting along the lines of what you said, is based on those constraints and drivers, it gives you the ability to kind of move different places in the process. If it can, because we're taking it out of the air, it's either going to go in the ash or it's going to go in the water. So, you have, I guess, some flexibility with being able to, I guess, retrofit and adjust and change with the rules. And so it sounds like that's been some of your guys' considerations as well.
I mean, that was definitely a facet of us getting away from Trona was the sodium byproducts are 100% soluble. That's just how it is. That's science, right? Where calcium-based salts aren't nearly as soluble, and that makes a big difference on the characteristics of leachate.
Okay,
I
appreciate that. Yeah, go ahead, Chad.
I would say for us, I mean, we've got a water program pretty much all across our fleet. Banking on some of the worst limits that are coming. But as far as on the air side, the biggest thing for us has been, low load operation, flexibility, with the capacity factors dwindling on coal units, making them as flexible as possible. So that's a lot of pre-SCR injection, a lot of, taking what we learned from DSI and reducing the SO3 and kind of applying that to some of our gas co-fired units. So I'm finding myself more and more using what I learned with DSI and kind of using gas as my sorbent for dropping loads even further because of the low SO3. But as far as new projects and things like that, we, kind of where we're at right now is just maintaining status quo and, doing the best we can to meet the limits that we've got. But as far as further enhancements outside of unit flexibility, the resources that we've got to implement projects and, from capital, we're just not there right now.
I think the interesting thing we've learned from a lot of the folks like you guys on the call, the utilities, about SO3 captures, a lot of the evolution of the DSI solution itself has been not so much pollution driven, but operational benefits, co-benefits, and changing where you inject and line how, and like you guys have described with the changing the loads is new problems, new opportunities, I suppose. So it's been
and that's where once you expose that, then that opens up new doors that you got to kind of address. And that's where, I've gotten more involved with everything at the plant, just because, we're opening up new issues that haven't been seen before, or at least since, we had SCRs, but those operators are many times long gone and they don't know how they used to operate.
Mm-hmm. Thanks, Chad. Don, what can you give us some perspective from the industrial side of things?
Well, we burn natural gas as fuel, so we don't have the water end after the use of the sorbent. So we're after efficiency increase is what we are trying to pursue, to minimize use of the sorbent, to minimize solid waste at the end with baghouse catch. We're looking for alternative uses for that baghouse catch. Nothing's really come up much yet, though there's some promising things on the horizon. But it's all about efficiency for us. Like, we've installed some static fans to increase mixing for better flight reaction, but COVID has killed our testing program for that. So as soon as we can get people traveling again, then we'll test and see what efficiency we've actually could gain out of that.
Okay. One of the questions from the audience, Don, I'll ask you specifically, and I'll add to it since it seems more industrial, but the rest of the folks can chime in. So the question is DSI moving to SO2 emission control, especially in like non-utility applications? Are you, I guess, Don, from your experience and maybe others you've talked to, are you guys seeing more widespread use of like dry sorbent injection for SO2 capture?
We use it for that. Our primary driver was chlorine, fluorine, but then we also get significant SO2 reduction out of it for compliance. So yeah, it works for us just with the modified hydrate.
All right, thank you. And just in generality, I was going to say that on from a sorbent supplier perspective, we see that in the industrial world, the low capital cost of DSI makes it a good first consideration in terms of looking down that pathway. So yeah, just reiterating kind of what you said in generality for the non-EGUs. And I know David mentioned that they are using it for SO2 capture already today. So obviously there's precedent out there in the utility sector as well of it being utilized. So Haley, I know we're going to turn the question over to you and let you be the last one to chime in terms of, what air pollution control quality problems you guys are dealing with and how you're attacking it. And I know we're still dealing with your audio is coming through, but for everyone here, we're doing our best to navigate through it. But yeah, we'd love to hear what you guys are looking at and hear your opinion on the question. And right now we can't hear you. And here we go.
There we are.
And trying to be as efficient as possible. And so that means, where we used to run with a little bit wider tolerances or ranges on, say, pH in the scrubber or feed rate to your hydrated lime or your ammonia. Now it's like we're dialing in those and trying to meet more strict targets with our operating budgets. And that doesn't leave us a lot of flexibility to absorb something that breaks or changes or when we lose redundancy. So a lot of it is just trying to get operators and maintenance to understand the importance of certain things so that we can operate as efficiently as possible and keep things in service and watch those feed rates and if there's for some reason a grind issue at limestone, so they understand how that affects everything downstream and what emissions at the stack it affects. It's not just SO2 anymore. It'll affect mercury, it'll affect selenium. So, and then, just like getting rid of the ponds, that's a huge thing to be able to deal with, where we used to have these giant buckets that we could put our water in. Now we're limited to tanks that have to in processes that we have to send the water through, and you only have so much buffer time. If one of those trains breaks, you only have so much storage. So, it's looking at a unit being restricted by water now, instead of just things like coal or pumps and things like that. So it's a different world, and it's a lot of education and sitting with the operators or having sessions with maintenance just to make them understand.
And I have to, hopefully you guys can hear me now. There was a little sketchy there for a little bit. So Jerry, I appreciate you supporting me and keeping the ball rolling here, but I was having some internet issues. So I'm going to stay on audio just to make sure that I stay here the rest of the time, but you guys don't need to see my face. You guys just need to see the panelist face.
It's an improvement for everybody and all the aspects of it. So we'll let you run with it. If your internet drops off, we'll pick up for you.
Thank you very much.
You're welcome.
Okay, so to keep us on track, I want to kind of basically play 1 to 5 word answers here, just words that kind of come to mind on this question before we move on to the DSI specific ones. So we'll go kind of rapid fire. I wanted to ask, considering that a lot of supporting industry support vendors also follow DSUA in addition to end users and our colleagues in the industry. I wanted to ask, so supporting vendors are constantly evolving as the energy market does. What are characteristics your company's value in a partnering vendor in today's marketplace? So we'll kind of go rapid fire here. Chad, why don't you go first? Just things that come to mind.
So with the limited resources in our industry that we're seeing today, I would say technical support.
For sure. No, that's a good one. Dave, what about you? What's AEP valuing these days?
I mean, we value companies that work with us as business partners rather than vendors. Yeah, we sort of put companies into 2 buckets: suppliers and vendors. Vendors just want to sell you a widget, where suppliers want to work with you and get to a better solution.
Totally. Yeah. Partnership mentality, very important. I think the best vendors value that. That's good. It's a good one. Don, what about you?
I agree with that supplier mentality. We need the partnership because our demands evolve regularly as our stakeholders change. So that flexibility is critical to us.
That's good. That's good. Haley, what about you? What's LG&E valuing these days?
I think it has to do with, not just being able to have a technology transfer, but that network of people that suppliers have and vendors have, with other utilities. And so if we have an issue, that's kind of our lifeline to be able to get in touch with maybe other people that might have that same issue. And you all are kind of the hub of that can do that. And so if vendors have 30 customers, then that's 30 people that we can ask a question to.
Totally. Yeah. It's kind of a teamwork approach. I think we've definitely gotten better and better at that as the industry's evolved too. So encouraging to see that over the years. Okay. So we're going to transition to some DSI specific questions. I know we have a lot of technical experts that follow these, and this is probably the most interesting parts of the webinar to them. So we'll spend a decent amount of time here. First question I want to ask into the DSI specific categories. So we all work on projects. Projects are the lifeblood of what we do for our companies. And each project, I feel, tells its own story. And I'm a big storyteller. I like listening to stories. I actually want to ask you guys, what is the most interesting DSI related project that you all have worked on in the last year? I was hoping that you could tell us about that. And Dave, let's start with you.
Yeah, so this was at our Rockport plant, which is two 1,300 megawatt units that are burning mostly PRV coal. And we use sodium bicarbonate there for SO2 control. And we actually have a pretty high efficiency removal rate there. We had some issues with our silos and the method that we were using to pull the material out of those silos. And so we actually retrofitted in mass flow cones into those silos. That was actually a really cool transition. As opposed to using mechanical means to pull material out, we're using gravity in our favor. And just to go, we started going down the path of trying to aerate the silos. We did some CFD modeling, and the blowers kept getting bigger and bigger with the nature of the material. And it went from the mass flow cones being uneconomic to being the obvious choice. And between it's a two concentric cones, and that interface diameter between the two concentric cones it's supposed to be bigger than the stable rat hole dimension of the material. And for us, the modelers told us it could have been a 15-foot diameter interface. And I was like, you know what? I don't want to screw around with this. I'm at one chance to do it right. Let's make it 20 feet. And it's worked like a charm. That thing is, my one regret is that we only did one silo cone per unit, where we should have done two. And that was a COVID hit. We cut back capital. That was one of them. And I was on a deep dive for that project a few weeks ago, and they were trying to drill me on what we could have done differently. Could we have gotten by without doing the cones? And I point blank told them, my one regret with this project is that we didn't do all four.
and that is a talk about innovation, because that's definitely a first. Remind me, how big are those silos at Rockport that we're holding?
They're 45-foot diameter.
Ooh, significant project, and that's awesome that it's working like a charm. So you have the plant now is the favorite silos and the not so favorite silos.
Yeah, they use the silo cone silos. They would rather just have those on all the time.
That's right. That's a good one. Haley, what about you? And I know you do a lot of stuff just besides DSI, but what's your favorite most interesting DSI related project in the last year?
I would have to say, can you guys still hear me? Just doing a check.
Yep.
Yes. Okay. I would have to say that probably putting in, I'm going to put a tag out there for you, but the Michelin injectors. They're pretty cool. So
shameless.
That's why you can't even show your face right now, Mitch. I understand.
Don't worry. Don't worry. There's a big grin on. I'll paint the picture. It's all good. Keep going, Haley.
So, the obvious dispersion benefits you get from them is easy, but the one thing that was pretty cool about them was the guys that operate our lime system. I put these on one of our units before, probably a year before the other one, and these guys that work these systems, they were asking me all the time, when are you going to put the injectors on this other unit? When are you going to put them on? And it was just because of the ease of, they didn't have any pluggage issues and those kind of things with the injectors. So it was neat to have the guys who actually work on the system be asking for something, because usually it's us as engineers pushing things down throats of the operators or maintenance, and they don't want to change and things like that. But this was just one of those cool ones that they actually saw the benefit and were asking for it to happen faster. So.
And we'll get into some reliability stuff later in this topic, because that was a fun project. So that's good. Thank you for sharing that, Haley. Don, what about you?
Well, for the last year, rather than DSI projects, most of our efforts gone into production. With everyone trapped at home, they remodeled their bathroom, and so we've been making a lot of time. but we've got some pending ones. The earlier mentioned static fan intrigues me. I think there's a lot of opportunity there, and we're looking forward to bringing that one to fruit.
Well, I think Don and both Haley kind of echoed this a little bit too, and Dave, in fact, has presented on the past webinars. I think the importance of, as well as Chad, the importance of dispersion. I feel like the utilities, if you guys have gone through this a long time and have understand the benefits, and as I go out there in the industrial sector, even just last week, when you stick those duct cameras in there and you just have a lance and you see what little bit of plume you get out of the tip of a lance and consider the cross-sectional area you need to cover. And it's pretty enlightening, and to see the evolution of, I'll just call it the injection grid, if you will, and how you optimize it, because I still think there's a lot of people that could learn and hear from your guys' experiences are valuable there, because it's a lot of people still just, I think, just sticking one lance in and just calling it a day. It's still out there.
Well, it's worked for us so far, but maybe we can do better.
There you go.
Incremental improvement. We're all about incremental improvement. Chad, what about you? I know you're doing all sorts of stuff at Duke over the years. What's your favorite one over the last year?
Yeah, so kind of got into this a little bit earlier, but kind of using what we learned from injecting hydrated lime ahead of SCRs and low load SCR operation, and kind of transferring that knowledge over to gas co-firing. We've been doing a lot of that. And also with that is more integrated controls. We've got performance curves for our hydrated lime systems, integrating those SO3s into SCR models. So if you're injecting a certain amount of hydrated lime, then that automatically allows X amount of NOx removal at X temperature. So kind of just making everything work together has been pretty cool. We're still working on implementation for that, but trying to take out as much that the operator has to think about all these different variables and implementing it.
Very good. No, and I also, Chad, I view you as really an industry leader, just switching topics on the system reliability side. I know you've done a lot of presentations that have been cited a lot in the industry on system reliability, and certainly some of the benefits that Duke has seen. So I wanted to the next topic. So my next question is really system reliability has long been a focus of continuous improvement with this technology. And I was hoping to ask all of you to please share a lesson learned on how your company improve the reliability of DSI technology within your fleet, in hopes that a listener might be able to apply that to their facility as well. And Chad, let's just start with you, man.
Yeah, so for us, it's been conveying air quality and getting the moisture out, because the carbonate formation that everybody sees, the scaling, is all relative humidity dependent with natural constituents that are in the air. So if you take that relative humidity piece out of it below 8%, the carbonate doesn't form. So that's been our attack at avoiding pluggage. And then outside of that, it's normal bulk conveying stuff, making sure the velocity is right, the symmetry of the system is right, and that's worked for us. And we've got multiple systems now that have run for multiple years without pluggage. So it's worked for us.
Hey, Chad, real quick to add on to your comment about relative humidity. I feel like over the years and folks I've talked to, that don't necessarily understand all the chemistry associated with that. The mentality is just cooler is better. But in terms of understanding the essence of relative humidity, that's not necessarily the case under all conditions, right?
Correct.
Okay, good. I think that's important for people to
so the temperature is essentially just a catalyst for what's happening there. So if you drop the temperature, you're going to slow down the inevitable, but unless you get the moisture out, it's still inevitable.
Right. In the sense of moisture is fixed, but temperature drops, you're actually bringing yourself closer to the dew point.
Yep.
Okay. No, that's a good distinction.
That's a very important observation, and it's encouraging to see some of those lessons learned and findings be implemented in other projects. And like Dave, I know AEP is implementing some of those lessons learned, but
absolutely.
What about you, Dave? What about system reliability?
you know, I think one of the things that we're trying to get away from is, you know, having, you know, dead blow hammers in different areas to try and keep things moving. You can see, we just redid our system at Rockport, and the old system that was there, you could see there was all sorts of mallet marks on the way bins or different things where it wasn't flowing, and they just, they'd send someone out there and beat the hell out of it. And, really just, to me, the lesson learned is use the material properties, use that in your favor and design around it rather than just, this is what you get because this is the system we make. Versus, the angle of repose, the material, the material of construction of the bin, that all weighs into it. And, we've seen big improvements there for sure with that.
Very good. Very good. Don, I'm gonna go to you next, and I think you have probably the most obvious answer in that. One way to improve system reliability is that you don't need to inject anything sometimes, right? So, but Don, what about you? What are some of the things related to system reliability that you guys have experienced and gone through?
Well, I feel better after Dave's discussion of the mallet marks in that our systems are much smaller. I mean, he talked about a 45-foot diameter silo. I have a 6-foot diameter silo. And that we've got air injection in the cone, dead blow hammers on the walls of the silo, and then the occasional manual approach. But the biggest problem that we've had has been in the feed line into the lance, in that we rely solely on Mr. Bernoulli to provide low pressure in the lance to just suck it up from the loss of weight feeder. We have no forced air. And so with that low velocity, scaling is an issue. And the humidity in the air is just what's in the room. Mm-hmm. So we have gone to the brute force and awkwardness approach of every time anybody walks by one of those flexible pipes, you use the whack it method. And that knocks things loose and it prevents scaling. And it's worked for us for over, I guess, a couple of years now. It's actually been very functional. So just it's just on everybody's routine. When they walk by the feeder, they whack it.
I like that, the whack it method. We're all very familiar with that. That's DSI 101 for us that have been in this.
And we have a simple system and a simple solution.
Very good. And last but not least, Haley, what about system reliability and your guys' efforts?
Like I mentioned before, the pluggage issues have pretty much become non-existent with switching over to those injectors instead of a lance in itself. And so that has helped allow the guys to spend more time, walking down the systems to find other things or doing some preventative maintenance instead of just working on those plugs from time to time. So that's helped a lot.
Yeah, no, and I think improving system reliability is a wide-ranging umbrella that certainly is dependent on plant to plant. For those that are listening, Jerry, I know that you wanted to ask a couple audience questions. I'm going to turn it over to you on this one.
Yep, no problem. We got a couple questions from the audience, and I think in kind of one round we can address a couple of them. So our panel I got a lot of experience in a variety of different sorbents, calcium, sodium, different grades of calcium out there. Be interested to hear your perspectives, observations in terms of, we'll just call it sorbent quality, in terms of what the impacts on DSI operation, and then what your guys' experiences are in terms of I'll call it the balance of plant effects, whether it's disposal or on water treatment, whatever it may be, whether it's enhanced hydrates to standard hydrates to sodium sorbents, just in general about your experiences and comments on the sorbent side of things. So tell you what, Haley, let's start with you and hear your feedback on this and your experiences.
So as far as sorbents, extra benefits, I think is what you're asking.
Yep.
So I mentioned a little bit our main thing is for SO3, which is your blue plume, but we found really quick that the air heater pluggage, helping with that is probably the biggest deal for us. And keeping our, we talked about reliability, keeping our whole units reliable, not just the DSI system reliable, by using that on the air heaters. We went from, we have to do air heater washes every 3 months to now we do them once a year with our major outages. So, and we know that if we do lose that hydrated lime on that air heater, that it, it'll cut down that length of time that we can go and run. And, some of our plants, with today's changes, get more outages than they used to, but the two here usually run at base load, so we heavily rely on being able to use that and make sure that that we don't have system issues. The other thing is with the chlorides at our scrubber. It helps a lot with some of the coal that we're getting. We mentioned that we get some not so great coal now, and some of that is very high chlorides. And the hydrated lime, I think we have done some testing and proven that it will also help capture some of those chlorides, and so we don't cycle up our chlorides so fast in our scrubbers. So we're allowed, we can reuse that water and cycle it back to our scrubbers and be more efficient that way, and don't have to process so much through our water treatment in the end. So that's another item that is just kind of something that we get because we use hydrated lime, but it is very helpful and it's quantifiable.
Now, have the different grades of, I think you guys have kind of tested and worked with different grades of hydrated lime over the years from the times you installed DSI. In terms of all those the different co-benefits and things you're trying to go after, have you had different experiences or observations about the efficiency or benefits or challenges as you guys have used different grades of hydrated lime there?
We started out with the basics, and then as they developed, each company kind of has their own higher reactive type or more surface area type lime, and those we have proven easily that those are more efficient, and we can use either less, but most of the time the plan is our hydrated lime systems are limited to a feed rate to certain areas, especially up to the air heaters, and it allows us to get more benefit with the same amount. So that's kind of what we go for, is not really cutting back on the amount of lime we use, but being able to get more removal with the same amount with those new products. And we usually either use, we got green probes in the ducts that we can check those numbers with when we go to test a different type, or we also have had the wet method that we've used and checked as a backup. So that they seem to be working really great, and it does help. And it some of those, they cost a little more, but because of the added benefit, it makes sense.
Got it. Thank you. Thank you, Dave. Same general question, and again, I know you've got current experience with obviously sodium and calcium and probably different grades of hydrated limes over the years. So, in terms of just DSI operation performance, balance of plant considerations overall, like what could you share in terms of the sorbent side of things?
So, there's pluses and minuses for both types of sorbents, right? Mm-hmm. With sodium-based sorbents, they, and you're going to not like this, but it's okay. They are more reactive. They on a molecular basis, you don't need near as much of you get better reactivity on the sodium side, but the problem is if you don't go after a really high removal rate of SO3, if you don't get down below 5 ppm, you're going to make a giant mess in your unit. So, I mean, there's a lot more risk there with the sodium. Whereas with calcium, you have a lot more margin. Now, the biggest drawback with calcium, in my mind, is you can get into, we've gotten into a couple spots where with lime injection that our units get curtailed because of opacity issues. Now, part of that might just be an AEP specific issue because sodium has sort of allowed us to relax on some of the maintenance activities on our precipes. And we're addressing that now. But, that if you don't keep up with precipitator maintenance and casing leaks really can eat your lunch on that issue for sure.
Okay. No, good to know. Thanks, Dave. Don, any insight in terms of sorbents that you want to pass along to the audience?
Well, I mean, we ran uncontrolled for years. Then regulations came into play for acid gas from our industry. And we've gone through the full range of hydrated lime, trona, hydrated lime and bicarb, and have settled on an enhanced hydrate that gives us great control with feeding less material. So it's certainly seems to be the best solution for our situation of natural gas with acid gas from the raw material.
Did you guys have any experience with all those range of products in terms of on the disposal side of things? Anything you can share there, since that's a common thing people are having to address as well?
Our only real issue in the past was that there was so much more of it. By feeding less material, we reduced our solid waste load. There was no hazardous issues in the past. It wasn't that kind of problem.
Okay. All right. Sounds good. Chad, turn it over to you.
So I would say, for the most part, we basically standardize on a high reactive product just for the benefits that everybody's talked about, higher, better utilization. We're able to put less particulate loading on the unit, less potential layout at lower loads when you don't have flue gas velocity, things like that. And, to Dave's point, I have also been a longtime sodium user. And I'll agree that the reactivity is superior, and at least with an SBS system where we inject liquid, the distribution is second to none. But even with the higher reactive materials now, we are approaching those I would say equal to or slightly better performance of that SBS system without the fears of the liquid sodium bisulfate formation and all that. And that's just the nature of that beast. And I would say the calcium products have definitely closed the gap over the years. And if we were to put a new system in today, and the last 2 new systems we put in, it's been a no-brainer to go calcium, just because of the ease of use compared to the sodium.
Okay. Real quick, just to tie into, we got another quick question that I thought would be somewhat relevant to what we've been talking about. Is someone said they have a baghouse application. I know some of you guys have ESPs, but also deal with baghouses as well. We talked about the importance of dispersion. Now, this question is around how do you guys value or see the importance of dispersion if you have a baghouse? Do you still feel that it's as critical? And what have been your observations? So I see a lot of head shaking. So whoever wants to chime in on that,
I'll take that one first. So I think I've been on the record many times saying that the faster you get the material distributed, the better. If you're targeting a certain material, because when you say, you're going to rely on that baghouse, that in-flight time, you're not going to stop reacting that material with other stuff in the flue gas. So essentially you're wasting that material for something that you may not be after. So for in-flight capture, it's critical to get it distributed as quickly as possible to go after those high reactive acids. So that if you don't have contact with high reactive acids and you wait till the baghouse, that sorbent's going to get used up on other things, CO2, SO2, different constituents.
And if
there.
you had any observations or have any concerns that if you don't get ample distribution before your baghouse, that will carry over in the duct, that'll carry over to the distribution throughout each one of the compartments as well, and thus kind of have a trickle down effect on.
Yeah. So you may have one compartment that's, heavily coated, and then another one that's got little to no coverage.
Gotcha. Don, I know you guys got bag houses. Have you guys had any observations along those lines as well?
I mean, our only experience with it really been to verify the in-flight issue is we've tested immediately before and immediately after the baghouse and found no reduction. All of our actions in flight.
Interesting. Okay. All right. Thanks, guys.
We have a baghouse unit out west. One thing just to add on to what Chad said, what we've seen is that, if you're going after just a moderate removal rate, dispersion isn't all that big a deal, but there's an inflection point and it's different at each unit, whether it's 50% removal, 65% removal, 70, somewhere in there, your performance tails off if you don't have good dispersion. So at that unit out west that we have, we only need a moderate removal rate. So dispersion in that case doesn't matter per se. But if we wanted to go after pretty high removal rate, then we would have to put in some sort of dispersion to get the better in-flight capture, 100%.
Yeah, you're dealing with exponential chemistry that, like you said, it gets linear, and then beyond that tail end of that curve, it takes a lot more to get a little. Yep. Okay. Thanks.
And I'll just chime in real quick on ours. We had, like I said, we have the hydrated line before the air heaters. Our secondary injection is before the bag houses, which is after the air heaters. And, being able to disperse the product better before the air heaters allows us to either eliminate it on some units at the bag house inlet or cut it way back. So I guess it doesn't directly answer the question of does it matter before the bag house if you disperse well, but it does. Dispersion in general did help greatly either eliminate needing to have that secondary point or reduce it a lot.
Yeah, even as a sorbent guy, I'll be the first one to double down and say that you can have the best sorbent in the world, but if it doesn't come in contact with the acids, it's never going to react.
Yeah, and that myth that if you have a bag house, you've solved the mysteries related to DSI. I think we're learning it's a solid conclusion. That's not the case. Like we kind of thought.
There have been a lot of myths in this industry over the time that I've been involved in, and that's been the fun part is understanding those myths and debunking or getting further clarity on what those are.
DSI Mythbusters edition, right?
That's exactly.
I love about. So I know I want to transfer a little bit to like a little mentorship / growth type of topic, but this is kind of a nice segue. So there's the last DSI question, and I was going to ask if you guys could change one thing about your DSI solution, what is it and why? But I want to rephrase that to be that if greenfield new user is designing a DSI system from scratch with all your guys' experience, what is the biggest piece of advice you would offer to a design team as they're designing a new DSI system? What's the most important thing in your minds to make sure that they take into account when they're building that? I'd like to start with Haley.
I would think that, as we've added new systems, the biggest thing I have learned to add and gotten a lot of great use out of is having a system that has total redundancy. For many reasons. One, of course, is reliability is the huge one. The other one is with all this trucking issues and things that we've had, it gives us a lot of more storage capabilities. So we have more on-site storage with those redundant systems. And then finally, being able to test things. well it's a huge help, because I can put a new test product in one whole silo, one whole system, and have my regular one in the other, and be able to seamlessly switch from one to the other, within minutes. And so, I would always, if possible, I would always try to have, a totally redundant system, if I was putting in a new one.
Really good, really good. Dave, I know that you kind of are in a unique situation that you guys have active projects. I've been doing this for a while. So what about you?
Yeah, I think, it's nice. I've been on a few different type of technology transformation type roles, between fixing the scrubbers that were corroding to nothing, to, DSI systems that were built just as an afterthought as part of the scrubber program. And, I'm happy that I wasn't on the bleeding edge of this one. Thank you, Chad. I'm going to throw this out there, but the dehumidification really, I think, has made a big difference for us in general. It's just, it makes, in general, for a DSI system, for it to work and stay in service and work reliably, it needs to breathe, right? And to breathe, you have to have air paths, and air paths bridge over with wet material. That's just how it is. And we, I think in the past, before we had dehumidification, there was a lot of just built in that, operators assumed that this material is garbage and it just plugs up all the time, and you just have to hammer it to keep it running. And that's really not the case if you have the right design.
Yep.
Yeah, no, and that's Chad, I know that you've been referenced a lot with dehumidification. What do you think? what do you think about that piece of advice you give to a new engineer designing a DSI system?
So, I'm going to answer both questions. The earlier one, because I thought I had a pretty good response to it.
Yeah, let's hear it.
As far as the new system, I would say just don't take shortcuts, because that's where a lot of the myths come in. Of all you got to do is get it in the duct, and all these other myths that we've heard over the years. Don't take shortcuts for what the industry has worked long and hard to understand, because it's there for a reason. Distribution being one, the air quality is one. It's just take what this group has done and honor it. And then the second part to that of what's one thing that I would change is I wish we would have done this and not spent so much time on reliability of these systems, so that we could have benefited from what we have today 5-10 years ago. Because I think the industry, now we're kind of getting into we're dwindling down on coal units and things like that. Whereas I think some things may have been different if we had applied this technology, 5-10 years earlier.
That's actually a really good point, because I know, speaking from the system supplier perspective, there are shortcuts taken to try to save capital. And I think time and time again, the industry has shown that
you're going to pay for it.
You're going to pay for it, and it's justifiable to put it up front, because we're doing it as retrofits constantly to do that. So the market has proven that it is worth it to invest sooner rather than later and stuff. And that's a really good point, Chad. I'm glad you mentioned that. Don, what about you?
Well, my advice would be, as a small system user, don't think small. We started off with the super sack program, bringing it in your 1-ton bags, and it should be in bulk. That the labor is just extensive on running bags around, finding a place to store bags, et cetera, et cetera. Think big, go bulk.
That's I think a slogan that Jerry and
I like that.
Yeah. He'll pay me later.
There's the plug.
No, that's really good. Really good discussion. This is great so far, guys. So the last plan topic I have, I want to go towards mentorship growth, which are key foundational aspects of why the DSUA exists as an organization. We're an information sharing, we're a career development, personal development organization, nonprofit. So I think it's important to spend some time on that. I know that this, when people say mentorship growth, it's usually it's implied that it's for quote unquote green people in the industry, right? The newbies. But I think myself, Jerry, everyone on this panel, DSUA firmly believe that, to do it right, it's all about lifelong learning. So whether you're in the industry for 1 month or 30 years, lifelong learning is part of getting better, getting 1% better every day type of thing, creates healthy culture, that helps us get better. And one of the things I wanted to ask you guys, maybe not, I know I asked you about a piece of advice related to DSI design, but if somebody in this industry, what would be one piece of advice you would give to a new or experienced full-time employee working in this industry? Don, can I start with you?
Stick with the fundamentals. It's come up several times today, but what matters is chemistry. And don't overthink it. Don't fall into the myths. Go to the basics. You learned it your second year of college, and it still applies.
That's good. That's good. Haley, what about you?
I mean, if it was a new engineer coming into this industry, I would say spend as much time in a control room and with an operator walking around as you can. You learn so much, from the people that are out there every day and what they see, and they don't necessarily tell you those things unless you put yourself with them and spend some time. It's not like they shoot off an email or call you when something happens, especially because these guys are working around the clock and weekends and things like that. So if you just go out there and make rounds with them, or sit at the control gauge board with them, you can really get a lot of valuable advice. You can also get a lot of non-valuable advice at the same time. But it's usually entertaining. But anyway, it is really good to lean on those guys that are out there using the systems and what they see and what they hear, and the little quirks that they've found work. Sometimes we get a little, tunnel vision with just being very technical, and we have to be put a little more common sense and just real experience, and those guys have it. So I would say, spend a lot of time, as much as you can, just out and about with the people that run things.
So a follow-up question to your comment, Haley, that I've always wondered is, so all those experienced people, I know people are retiring, you get a different generation mindset coming in, but you also have younger folks. How do you guys capture that knowledge and experience, as there seems to be more turnover today than maybe 10 years ago? How do you kind of bottle up all that experience and transfer it to the new folks so that you're not perpetually going up the same learning curve? Or they are, I guess.
That's a struggle, and we learn the hard way sometimes of something, if it's something that happens every 2 years, as part of an outage or things like that, you don't realize that you've lost that person that knew how to do that one thing. And so a lot of times, just like I said, spending time with those people. Also, just ask people, talk to them, talk about what makes sense. We've added a lot of informational items on our DCS screens. So the screens that they use, instead of just, using those to monitor real-time things, we have little pop-up boxes that you can click on, and it'll give you, for instance, kind of a how to react to pH at the scrubber. So if, SO2 goes up, what are the things that you can do to affect it, and how should you do those things? Like, you don't want to drop your pH, or you don't want to increase your pH or drop it by a huge amount, because that'll just like screw up your total scrubber, and your mercury will go up, everything will go up, and it'll be horrible. But it's just kind of those little things, and if they know they have those to go to, you know, that'll help. And then just extensive training. We've developed, we have actual trainers now as part of our operations system group, and they're in charge of making sure that things get, when we put new systems in, that they get added, or if somebody's leaving that has years of experience, like I know we had recently, not related to DSI, but like a fire systems person left. You know, that was like one person did that for 20 years, and, you know, we had to get all that knowledge and document those things. So a lot of times if you give a person that knows nothing about a certain system to that very person who has a whole lot of knowledge, that person that knows nothing asks so many questions, you know, it's not like they're assuming anything. So they get everything documented, I think, better than if it was somebody who'd been here for probably, you know, 15 years or so and think they know everything. So they're not going to ask
get the blinders.
But then when it comes around to it, then they're like, oh crap, I didn't ask this, you know, I just assumed this, and that's not the way it is. So that kind of helps too, is if you have somebody that's really green with somebody really experienced, they're more likely to ask the question.
Oh, that's good. Thank you.
Dave, what about you?
I guess for someone new coming into the industry, I'd say get yourself as well-rounded as you can. And one of the things that's really helped me in my career is getting out to the plants, like you say, spending some time in the control room. You know, the operators know those systems a whole lot better than the system owners do. You know, you're calling on the system owner, but if you really want to know about the nuts and bolts of how the thing runs, talk to an operator, because they know, and they've had to troubleshoot and fix it. But also what helps me is if I can visualize something. So I've been in a lot of tight spaces, and sometimes it's uncomfortable going in those tight spaces, but in the long run, you will benefit from it. I've walked down just about every last piece of equipment in the coal unit that you can, you know, all sorts of different ducts, scrubbers, been in the SCRs. You know, it's one thing to see it in paper. It's another to visualize having been there and seeing, oh yeah, this is what that looks like. So, you know, if someone was coming in to be a DSI person, I'd say, listen, you need to understand SCRs, you need to understand air heaters, you need to understand scrubbers, because it all plays into what we're doing.
No, that's really good. Yeah, nothing replaces hands-on experience, right? It takes more conscious effort to go to that level, but I agree. The learning curve speeds up so much if you can do that and apply yourself that way. So that's excellent. Chad, last but not least, what about you?
So I would say, you know, to kind of close the loop on what everybody's already said, I from my perspective, and kind of how we have been more or relied more procedural focus, as you know, we've had these large amounts of turnover. You can't proceduralize how to think. You still have to think and ask questions and wonder why. And a lot of those questions start to get answered from, you know, like Dave mentioned, walking things down, and you know, if you see a pile of hydrated lime building up in this area inside the ductwork, well, why is it doing that? And that's pretty much just how I have kind of grown up in the industry, is, you know, asking why, and, you know, why are these systems scaling? What's causing the scale? And, you know, kind of gradually, you know, peeling those layers of the onion off. And I think that too often now we just more rely on what this procedure says. And, you know, we lost some of that why and basic understanding of fundamentals, like Don said, you know, getting back to the fundamentals of why things are happening.
No, I was just going to say, I'm glad you referenced Don, because I think it's a great callback. You're never going to be able to answer or give one answer to address every question, right?
Yep.
We develop our
Exactly.
skills to think, critically think, and problem solve. And that, if you can think in the fundamentals, it allows you a completely different degree of flexibility that if you are just looking for a straight line answer, you'll probably won't even see if you don't get back to those fundamentals. So really, really good. So kind of reversing that, I know I kind of asked that question in relation to an experienced person like this panel talking to a new industry employee. Let's get a little bit of introspective here to wrap up the mentorship growth. I want to ask, what is something that you guys have learned in the last year that has made you a better engineer or a better employee compared to a year ago? And this doesn't necessarily just have to be technical detail. It could be a skill development that's non-technical, but because I think that's part of being a good employee is developing not only our non-technical or technical, but our non-technical skills. So what is something that you guys have learned in the last year that you didn't have before? Haley, I'm going to start with you.
All right. I think with COVID and all the restrictions, with not being able to go visit places, not being able to have meetings in person, it's been quite a change. And you kind of, for a while, I felt like I lost that connection to other utilities or other, to the suppliers, and just that being able, the conversations you have that you would have in person that just don't flow as freely when you're on a phone call or a WebEx or whatever. So getting used and learning how to use all those tools that you didn't use as much back then, to be able to do knowledge transfer and ask questions and learn from each other, and not, learning how to not get disconnected, I guess, was like a huge thing, and not just get siloed into, where you work, the one place you work and the few people that you work with. So that was probably a big thing for me, was just, learning to not only use those tools, but to put the effort in to keep those relationships going.
For sure. No,
It sounds like that's along the lines of communication, like your form of communication, maybe even the frequency and how you direct it how do you capture that knowledge without being in the field? Whereas maybe sounds like more calls or more pointed discussions on certain things to make sure you don't miss because you can't be in the field. So yeah.
Right. And emails, making sure that you send like a summary of everything you talked about on the call. When you have, 30 people on a meeting, that's a call, it's harder to capture all those things. And, you don't read faces, on the phone, like you do in person. And some people don't talk as much on the phone as they do in person. So to make sure you capture all the notes and things that were talked about in a meeting and send those out to all the participants so it doesn't get lost.
One other thing, speaking of skill development, I know we've talked about the concept of teamwork has come up multiple times in this discussion, and I know Haley is viewed. I mean, you're definitely viewed as by the industry as a mentor. You are great and leadership development, all that good stuff, Haley. And you have one of my favorite sayings is actually on your desk. I can't remember exactly what it is, but if I'm putting you on the spot, what can you read it off for the group? Oh, and Haley, can you say that? Can you hear us?
It's like, this is going to be the most insightful thing in it.
I have like construction going on the other side of this wall, so I like mute my phone so it doesn't bother you all.
That's right.
No, it was something to the effect of, if you treat people like they make a difference, they will make a difference.
Right, and I think that's as we get, we're asked to do more and more as an industry with less and less. I think teamwork is of the utmost importance, and how you treat your teammates will impact how productive we are as a team, which is something I just want to highlight for the audience as well. But Dave, what about you? Personal development last year.
Yeah. So, when COVID hit, I still work from home, right? I only just recently in October started going back into the office, and that's still just 1 day a week. So for the most part, I'm working from home. And one of the things that I've adapted to and learned how to check and adjust on is getting away from having to print out things. I used to print out 11 by 17s all the time. And, you know, there is some advantage to having it on paper, right? It's just easier to mark up. It's easier to work with, but at the same time, I've figured out how to just live in the digital world and use the monitor for drawing review and trying to find stuff. And it takes, you know, it's not a big deal, but it you know, I don't even have a printer anymore. I don't know about you guys, but I've bought printers before and they last until the ink dries out of the cartridge, I think in like a month and a half. And so you can either print a whole bunch or print nothing, but it doesn't matter. And you try to replace the ink cartridge and it doesn't work. It's like so I've given up trying to print things out. We don't even have a printer at this point. So
You need to get a 11 by 17 Wacom.
Well, now you can ditch your magnifying glass. Now you just zoom in.
right, exactly.
Yeah, I actually still have to get. I've been procrastinating this for way too long, but I need way more. I need more screens to look at more things at the same time, right?
Yeah,
that was actually one of the first things I bought was a 27-inch monitor.
I am not. I don't know if it's laziness or if I'm not forward thinking, but that's what it is. Chad, what about you? Personal development last year.
So I think one thing is, you know, it's been ingrained in our heads over the years. And Haley, I think you mentioned it, so to listen to the operators and learn from them. But what I'm learning, we've got a whole lot of young operators now, and it's been a challenge or a change to, you know, realize that they don't have the expertise that we had before, and now kind of teaching operators what we've learned and kind of you know, just reprogramming yourself to, you know, helping them learn.
For sure. Yep. No, that's good. Don.
Haley actually took my thunder on that one. It was exactly that, the value of community and the loss thereof. And I guess then what I've done with it, that created some time available in the past year since there was less meetings to attend, less networking required. And so I've broadened topics. I'm now the sustainability guy. We're going carbon neutral. That falls to me. So I've expanded the knowledge base to some degree.
Yep. No, and I don't see a problem with multiple answers there, Don. That's definitely, something I've learned over the last year as well. It's paradigm shift type of thing and force you to think things through a little differently. So I just had one more fun question that I wanted to wrap up with. We have about 6 minutes left, and I don't think we have any audience questions remaining, right, Jerry?
No, we're good.
So one of the things in asking the panel to review some questions ahead of time to help make this as productive of a discussion we could have, which I think we did. This has been really, really phenomenal, guys. You guys, panels brought their A game. But Haley had the idea, knowing that, you know, hopefully next year we'll be able to have an in-person conference as opposed to the webinars we've been having, which have been fun, and we've made the best of the hand that we've been dealt, but I think we're all looking forward to getting in person again. Where do you guys think we should go for our next conference? Where should we go when the doors open up and we can do it? Dave, what do you think?
The obvious answer is Nashville. That
right.
is the home of calcium.
Yep.
That's right.
I'll second that.
Chad's got Nashville. Don, what do you think? Are you on the Nashville train?
Well, since I live in Nashville, come on in.
Yes, all right. Haley, what do you think? Your question, what do you think?
You know, I'm always partial to bourbon country, so Lexington was pretty fun when we had Reinhold there.
Well, there we go.
Well,
I can get on board with that.
It's official that we're having Reinhold. Duke is hosting Reinhold in Charlotte, so come see us in Charlotte in June.
Nice. Good location.
Absolutely. Right down the road from you, Chad. Thank you for looking out for me, man. So
I tried having it in Cincinnati, but that didn't go over so well.
my headquarters is literally right downtown. They have a powerful voice. I definitely get that. Well, cool, Jerry. I don't know if you have any additional thoughts. I know I don't think we'll have a problem with wrapping up a couple minutes early, but I definitely want to see if you have any final thoughts.
Last thing I'd actually, since we have a minute to get their insight on is, and we're talking about the conference, I'd be interested to hear is, what would they like to see out of a conference? Where the value would come? And I'm thinking along the lines of, I know the historical format of conferences, people giving presentations, but where's the biggest value you find? Is it, for example, networking? Should we be focusing on networking? We've always, DSUA used to make a point to have plant tours. Do you feel that's still valuable? Or again, should we be focusing on, collaboration and networking? Or, has the old format been of what you've seen out of conferences still the kind of path we should follow? And I'll open that up to whoever feels the most passionate about it.
I mean, so a lot of times, with the different conferences I've been to, I like one aspect that Reinhold does is where they have they basically force every group to have like a 5-10 minute spiel of what they're doing, get everyone talking somehow. That's one piece of advice. The other is I think I get more out of the after hours talks with people than I do in the show itself. Mm-hmm. So go someplace fun where you don't mind hanging out a little bit later.
Yep.
That's wise, Dave. It's what happens after is usually as productive, if not more so, than the conference.
And I think that goes back to Haley's comment about the communication earlier. It's always the meeting after the meeting.
Yeah.
Yeah.
That's when the creativity starts flowing.
Yeah. You guys have been, I obviously have a very strong opinion on that, and you guys just reinforced it. And that's why DSUA, the last conference too, the breakout sessions are always good, but that's why we decided we would incorporate some free beverages during those. It gets people loosening up and talking a lot more freely. So no, I appreciate the insight on that, guys.
Anything you can do to make people talk and open up is good, and build those relationships and somehow get people to transfer their who they are, like a quick, easy way. I don't know how you would do it, but a quick, easy way to get people to have a list of who people are, where they're from, and something to remember them by, and a contact method. And that way, you can build those networks. Because I think there's a lot of new people.
Yep.
There's a lot of us that have been here for a long time, but there's a lot of new people that could use, I'm sure, some assistance with things, and we could learn some things from them. And so a way to somehow get that network going would be helpful.
And I'm with you on that because, I'd say, thankfully, DSUA and even DHUG, all the utility conferences, a lot of us already know each other or historically have, so it's easy to run into people. But as a person who's attended a lot of industrial conferences, you do a lot of that where you read the name tags going by, and it becomes really, how do you drive that connection? Because exactly like you said, the utility market is turning over. So how can you create that network and make it easy so that folks have a convenient pathway to start that collaboration and communication? So that's all I got. I'll be quiet, Mitch. You can take us home.
No, and we're getting some comments in from the audience. I just wanted to thank the audience for joining, listening to us. This is recorded, obviously, so you'll be able to if you weren't taking notes or whatnot, or in and out of the meeting, like, you'll be able to come back and watch. I definitely want to thank the panelists. Like, I am very, very happy with how informative and knowledge and engaging you guys were with these questions. I know that you guys are all very busy, and I definitely appreciate you guys really investing your time into doing this and dealing with the technical difficulties we had. You guys are pros. You guys are absolute pros. So I
Mitch,
hope
your camera is off, so it's not all bad all the time.
Right. The universe is spoken. I get it. No, and yeah, just looking forward to the next one, and appreciate everybody's time. I hope you guys have a great rest of your day. Okay.
Yep. Do the same.
Merry
Thanks,
Christmas,
everybody.
Happy New Year.
Yeah. Merry Christmas.
Thanks a lot,
everybody.
guys.
Happy holidays. See you guys.
It's a
Thank you.
classic, see you guys next year thing. We'll end it with that.
Great bit. See you guys.
Take care.